In Chapter 9, we will learn some techniques used in speech recognition. Firstly, let's have an overview of speech recognition. Speech recognition has been widely used in our daily life. Have you tried ASR, automatic speech recognition? Some private assistant software like Apple Siri, Google Now, and Microsoft Cortana can provide naturally spoken interactive mode. By applying machine learning technologies, tech giants like Facebook and Google have released open domain AI-powered chatbots that are able to reproduce more human-like conversations. In-car speech recognition systems have become an almost standard feature in all many new vehicles on the market today. Typically, the driver's phone and voice are incorporated into car navigation, entertainment, and other limited features. Transcription of voiced contents such as broadcast news, meeting, conversational telephone speech, medical and legal records are also important to improve work efficiency. Some other applications like call center applications, robots and toys, speech-to-speech translation, dictation, and so on, have widely used the speech recognition technique. Speech recognition has become a typical application scenario of artificial intelligence systems. What is speech recognition? The goal is to automatically extract the string of words spoken from the speech signal. Speech recognition does not determine who is talker, speaker recognition, speech output, speech synthesis, what is the language, language recognition, what the words mean, speech understanding. For higher level, automatic speech understanding is the process by which a computer maps an acoustic speech signal to some form of abstract meaning of the speech. Speech recognition systems can be classified into different categories from designing views. A speaker-dependent system is developed to operate for a single speaker. These systems are usually easier to develop, cheaper to buy, and more accurate, but not as flexible as speaker-adaptive or speaker-independent systems. A speaker-adaptive system is developed to adapt its operation to the characters of new speakers. The difficulty lies somewhere between speaker-independent and speaker-dependent systems. A speaker-independent system is developed to operate for any speaker of a particular type, for example, American English. These systems are the most difficult to develop and most expensive. The accuracy is lower than speaker-dependent systems. However, they are more flexible. The size of vocabulary of a speech recognition system affects the complexity, processing requirements, and the accuracy of the system. Some applications only require a few words, for example, numbers only. Others require very large dictionaries, for example, dictation machines. There are no established definitions. However, we could say small vocabulary with tens of words, medium vocabulary hundreds of words, large vocabulary thousands of words, very large vocabulary tens of thousands of words. An isolated word system operates on single word at a time, requiring a pause between saying each word. This is the simplest form of recognition to perform because the endpoints of words are easier to find, and the pronunciation of a word tends to not affect others. A continuous speech system operates on speech in which words are connected together. That's to say, not separated by pauses. Continuous speech is more difficult to handle because of a variety of effects. First, it is difficult to find the start and the endpoints of words. Another problem is co-articulation. The production of each phoneme is affected by the production of surrounding phonemes. And similarly, the start and end of words are affected by the preceding and following words. The recognition of continuous speech is also affected by the rate of speech. Fast speech tends to be harder. From the technology perspective, speech recognition has a long history with several waves of major innovations. Most recently, the field has benefited from advances in deep learning and big data. The history of speech recognition has over 60 years. Many well-known companies have appeared and developed a variety of methods in designing and deploying speech recognition systems. The techniques for speech recognition began with the analog filter banks in 1960s. Then the dynamic time wrapping (DTW) algorithm was used to create a recognizer capable of operating on a small vocabulary. In the 1970s, researchers at CMU began to use Hayden-Markov model, HMM, for speech recognition. HMM proved to be a highly useful way for modeling speech and replaced DTW to become the dominant speech recognition algorithm in the 1980s. In the early 2000s, speech recognition was still dominated by traditional approaches, such as Hayden-Markov models combined with feed-forward artificial neural networks. Today, however, many aspects of speech recognition have been taken over by a deep learning method. There are some key techniques used widely in speech recognition. Typical features are extracted from the input speech signal like LPCC and IMFCC. In HMM model, DP, EM, and Viterbi are important algorithms to finish some task. Both acoustic modeling, AM, and language modeling, LM, are important parts of modern statistical-based speech recognition algorithms. Hayden-Markov models, HM, are widely used in AM tasks. Language modeling is also used in many other natural language processing applications, such as document classification or statistical machine translation. Artificial neural networks emerged as an attractive acoustic modeling approach in ASR in the late 1980s. Deep neural networks with multiple hidden layers became successful in large vocabulary speech recognition in 2010. In speech recognition based on words, there are three kinds of error: delete error, insertion error, and substitution error. There are two important evaluation metrics: word correct and word accuracy, standing for the recognition rate. Another metric, word error rate, WER, is the key evaluation metric in speech recognition. The lower the WER result, the better performance of the recognition system. From the view of evaluation metrics like a word error rate, we could see the evolution of speech recognition systems. The recognition task becomes more difficult when the vocabulary in the system is larger from single speaker digit to continuous digits, command and control, letter and numbers, and much more words. Continuous speech recognition of read speech and broadcast news faces the difficulty with naturally spoken sentences. As the technology advanced and computers got faster, researchers began tackling harder problems such as larger vocabularies, speaker independence, noisy environments, and conversational speech. Nowadays, spontaneous telephone speech is still a grand challenge. Telephone quality speech is still central to the problem. Vision for speech technology continues to evolve. Broadcast news is a very dynamic domain. For human listeners, speech recognition performance is consistent whenever in noisy or quiet environment, from low SNR to high SNR. For machines, the performance of speech recognition systems will be lower if the background noise is higher and low SNR condition. Human performance exceeds machine performance by a factor ranging from 4 times to 10 times, depending on the task. On some tasks, such as credit card number recognition, machine performance exceeds human due to human memory retrieval capacity. A primary failure mode for human is inattention. A second major failure mode is the lack of familiarity with the domain. That's to say, business terms and cooperation names. The nature of the noise is as important as SNR. For example, cellular phones. In summary, speech recognition has been a grand adventure for the past 50 years. The task has been difficult because it requires the expertise of many interdisciplinary teams. It incorporates knowledge and research in the fields of signal processing, acoustics, and physiology, phonetics and linguistics, statistics, AI, and pattern recognition, human-computer interaction, computer science, and so on. That's all for this session. See you next session.